Firstly, we would like to congratulate all the participants of the conference. Allow me to present a paper that is a result of collaboration between a number of authors. The article named "The Aircraft Automation Principles as a Basis for the Use for Information Technologies." The authors are Leonid Romaniuk, Martin Berners, Vitaly Kartashov, Igor Chehira, and Helena Tulaidan. The statement of a problem is the next. The ability of autonomous aircraft to follow trajectories with a small spatial trajectory displacement is the requirement of the type of aircraft which should be met the vast majority of the application, the fulfillment of which ensures the UA does not encourage obstacles, does not violate the boundaries or designated airspace, mountains separations from the other air traffic participants, or provide good recording due to the accurate positionings of the carried sensors such as cameras. The consequences of influences short orbital distance can range from mission objectives to saved critical events such as invasions into the undesigned airspace, or especially in the case of low-flying UAs, collisions with the aircraft obstacles. The idea of reducing complex relations results in the aircraft motions to a few parameters of the kinematic motions model was concluded that in order to create reference trajectories, the parameters of kinematic motions models should not be derived from the detailed records of measurements for all system and subsystem states from the detailed knowledge of the systems. Probably the idea that is direct determination of certain parameters of kinematic motions model is sufficient for reference trajectories creations. The effects of wind speed and directions of UA flight states was investigated. Appropriate parameters of a method of the solutions under the influence of the wind conditions are also the problem of UA logistics road planning, which is simultaneously takes into account of the UA energy consumptions, limitations, customer times windows, and the influence of wind conditions were solved. Accurate trajectory planning required information about the kinematic of dynamic model and named model aircraft motions for its proper trajectory planning in this paper. Kinetic models of Dubin aircraft motions is used to reference trajectory planning. The reference trajectories what are planning using the Dubin's motion models are described in details for the vast majority of mission scenarios, including obstacle settings and the application of a motion model particularly suitable for efficiency in flight trajectory planning. The vertical trajectory shown in figure 1b is climb segment that transitions between horizontal flights. A climb and distance are modeled by sudden changes in the trajectory angle gamma. This is also the approximation of UA motions model. Changes in the trajectory speed vk will be modeled as the approximations to sudden changes in vk as well. While the Dubin's aircraft motions model just roughly describe the motion of the real aircraft segment transitions, the simulated segment motions correspond to the real motion of the aircraft in the stationary flight. On figure 2 are described and calculation of the reference trajectory with the SCS segments taken into account Dubin aircraft motions model presented. While planning motion in obstacle-free space, in addition for the road segments are specified reference points A, B, C. Complete reference roads can also be planned as obstacle-free space. For this paper, the calculations rule was implemented in C++ programming language. For clarifying reference point A1, B1, C1 for SCS segments are drawn in figure 3a, and next results you can see at